My presentation is aimed at providing a basic understanding of how oil and gas are formed, how we explore for them, and how we produce them. And hopefully by the end of my presentation, I will have inspired some of you to take up a career in the upstream oil and gas industry. Okay, oil and gas are part of a group of fossil fuels, and this group of fossil fuels is made up of oil, coal, and gas. When you are talking about fossil fuels, we are talking about non-renewable high energy sources that are used to cater for majority of the world's energy needs. To give more context, statistics from last year shows that more than 60% of the world electricity was generated from fossil fuels, and this clearly demonstrates that fossil fuels continue to play a vital role in today's energy sector. Now, how do we form fossil fuels? For you to form oil and gas, the first thing that you need is a large number of marine organisms to die, settle, and accumulate at the bottom of the ocean. We call this accumulation organic matter. The second thing you would need to do is subject this organic matter to high temperature and pressure, and you achieve this by burying the organic matter much deeper into the subsurface. And at the right conditions, the organic matter is then turned into oil and gas. Coal, on the other hand, is formed through the same process. The only difference is the origin of the organic content. The organic content for coal is coming from plants, and the process takes place on land. Now, what are some of the critical conditions or elements that needs to be present for you to generate oil and gas? First of all, like I said, you need depth, you need temperature, you need pressure, and you need anoxic conditions. Anoxic basically means lack of oxygen. The reason why we don't need to subject your organic content to oxygen is because it will basically biodegrade and decompose and form what we call biogenic gas. That's why anoxic conditions are very, very important. Now, how do we achieve the temperature and pressure? You start off like on the left side of the slide. You start off with a layer of organic content, and then through time you will vary that layer into much deeper into the subsurface, and by doing so you are increasing the temperature and depth of the organic matter. Okay, and then now where do we start forming, or where do we start generating oil and gas? We are talking about a depth of about 2.5 kilometers and a temperature of above 65 degrees Celsius. And then between that depth and about 4 kilometers, that is what we call the oil window. And during the oil window, you are mostly generating oil, and sometimes you can have a ratio of gas to that. That is what we call now oil with associated gas, and this is typically what has been discovered in the oil basin last year. And then as you continue increasing the temperature and depth, you move from the oil window into the gas window. And the transition between these phases from the liquids to the gas phase is a gradual transition. And therefore, at some point, you'll be producing what we call wet gas. This is basically gas that has liquid oil in it. And then with more increased temperature and depth, you produce dry gas. And this is what we have in the oil field. Now, at the surface, near the surface, you might produce heavy oil based, depending on the conditions present there. If your oil interacts with some of the near surface biological processes, it will alter the oil, and then you generate heavy oil. And then, as you increase the temperature, you produce light oil. And as most of you might be aware, the oil that was discovered in Namibia last year is actually light oil. And that is what you want to discover. And then in terms of classification of heavy versus oil, it's normally just based on the API units. This is a convention from the American Petroleum Institute, and they measure it based on the specific gravity of the crude oil. So your heavy crude oil will have a lower number, and then your light crude oil will have a much higher number. Okay, now finding oil and gas. The process for finding oil and gas is what we call, we refer to as exploration. So basically exploring for oil and gas. When we are exploring for oil and gas, there are certain key elements that need to be present for you to form a hydrocarbon accumulation. First of all, you need the soft rock, you need the migration path, you need the reservoir, you need the trap, and you need the seal. A soft rock is basically your organic rich content that has been subjected to the right conditions and it has produced or it has generated oil. Now you need that oil to migrate from the source rock into the reservoir through a migration path, which can be a fault, as you can see. A fault is basically a crack into the ground through which the oil can migrate from the source rock into the reservoir. A reservoir is a rock which is almost like a kitchen sponge when you are washing your dishes. If you dip the sponge into the water, it will absorb and it will hold the water. So a reservoir is basically a similar rock to a sponge. And the trap is a structural configuration which can be sedimentary or as a result of a fault. As we can see in the image, a trap is basically a structural configuration that is able to trap the oil accumulation. And then a seal, as opposed to a reservoir, a seal is impermeable and no liquid will penetrate through that seal. So in the case where you have all these elements present, you form a conventional hydrocarbon accumulation. But in the case where you don't have a migration path, which means your source rock has generated the hydrocarbons, but they are still trapped within the source rock. That is what we refer to as unconventional hydrocarbon accumulation. And this is typically what is been mined in the US, and it's mined by through hydraulic fracturing. Now, the first step into exploring for oil and gas is data collection. How do we collect this data? We collect this data by acquiring seismic data, and as you can see on the left side of the slide, you are seeing a seismic vessel there. What happens is you send sound waves into the ground, and then they get reflected back to the surface, and then that reflected wave is then recorded and processed into a seismic section. The bottom left image basically shows an outlay of a real seismic survey, and it can be a big layout because we are talking about 8 kilometers long and about 2 kilometers in width. So what you then get is an image of the subsurface, which is typically looking like the top right of the slide. And then what you do as a geologist, you go ahead and interpret the seismic section. The reason for you to interpret is basically to build a geological story and then try to identify some prospects that you can drill for oil and gas. In terms of timing, a survey can take up to between 2 to 5 months, and an upstream industry is quite costly, and a survey can cost you between 20 to 60 million US dollars. Now, after you have interpreted your seismic and you have identified some drillable prospects, you then decide to drill an exploration well and try and see if you'll be able to hit something. Okay? And drilling an exploration well is actually the only way you can confirm if there's oil accumulation in the ground. There's no other way that you can find out about that. But it's worth noting that an exploration well does not confirm commerciality of a field. So that is very important to take note. So when there's a discovery, there's hardly any announcement of the numbers because you are still not certain on how large the field is. And then in terms of costing, again, quite expensive, 40 to 100 million US dollars per well, depending on different conditions. And then a number of other wells that will be drilled subsequent to the exploration wells would be appraisal and then production wells, but I will describe this as I go along. And then the images basically depict the different drill ships or drill rigs that we use depending on the water depth where you are operating. And as we are aware, the water depth in Namibia is what we call ultra deep water. We are talking about 3,000 meters, and we are using a drill ship to drill for, that is the rig which is designed to drill at such water depth. And then on the right, I'm just displaying the Voyager drill ship which discovered the Venus well last year. Now, after a discovery is made, you continue to drill more wells. These are what we call appraisal wells. The reason why you want to launch an appraisal campaign is because you want to quantify the reserves, number one, and then you want to flow test the wells so that you are able to quantify how much you'll be able to produce per day from each well. And then thirdly, you want to confirm commerciality because now you know the size of the field. And this is actually the stage where both of the operators, Shell and Total, are right now. They are doing the appraisal campaign in order to quantify the volumes. Okay. And then after your positive appraisal campaign, what the operator will do is write their field development plan, submit to government, and then approval. Once approval is granted, they can go ahead and develop the field. During the development phase, this is when you are building both your onshore and your offshore facilities that are required for producing the oil. And during the field development phase, this is actually where you pump in more money. Your capital expenditure can vary between 5 to 20 billion US dollars. And then in terms of schematic concept, you drill wells and you plug well heads on top of each well, and then you lay out your flow lines. This will be the pipes through which the oil will be flowing from the well to the FPSO. And then on the right, I'm basically just trying to show you what would a typical image look like in the subsurface. You have to imagine yourself drinking Coke from a bottle with a straw. What you are basically doing here is putting a bunch of straws into the ground, and those ones will help you to drain the oil out and bring it to the surface. Okay, and then after you have done your field development, you have drilled your production wells, you then move to first oil, you produce your first oil, and then after that you have to transport this oil from offshore to the onshore processing facilities. As you can see in this image, you have a production platform, and next to it there's a crude bio tanker which is ready to transport the oil from the sea to the land processing facilities. In terms of revenue harvesting, we are talking about 10 to 15 years after exploration has started, and a typical field will produce between 20 to 40 years. And then I want to talk a little bit about how do we get the products that petroleum products that we interact or that we use on a daily basis. I'm sure we have all heard of or used diesel, petrol, gas for cooking at some point. So what typically happens to the crude oil when it goes on land, you subject it to, you boil it in a hot furnace, and then you condense the vapor into a condensation cylinder. These liquids will condense at different temperatures based on their boiling point, and then you realize that your light fuels like LPG, which is petroleum gas, and then gasoline, they will come out at the top. And your heavy fuels like bitumen is basically the material that is used to make tarred roads. It will come out at the bottom because it's very heavy. And lastly, I'm convinced that all of us here today have used a product which is a derivative of oil and gas. You have either switched on a light bulb today, you have maybe kicked a soccer ball, you have filled up a car, or you have cooked using gas, or perhaps you have applied Vaseline or any petroleum jelly on your skin or your lips. And yeah, or some of the clothes you are wearing might actually be containing petroleum products in them. And then in summary, the upstream petroleum life cycle is a 5-stage life cycle where you start with data collection, and this typically takes about plus minus 4 years. And here we are talking about the low chance of success because of so many uncertainties and unknowns. And in terms of capital injection, you are talking about 20 to 80 million US dollars. And then after data acquisition, you interpret, identify prospects, you move on to exploration drilling, plus minus 4 years, still a low chance of success, and your capex or capital expenditure will keep increasing. And then after a discovery, you now launch your appraisal drilling campaign, you quantify your volumes, you declare commerciality, and then you apply for your field development plan, get approval from government, and then move on to the field development phase. And at field development phase, we are talking about plus minus 5 years. And here, obviously, because you now have a discovery, you are sure that there is oil in the ground, your chance of success will go up. And in terms of spending, you can spend up to 20 billion US dollars. And then lastly, the last stage will be the production operations, at which now everyone, including the operators and the government, can reap some revenue. And of course, the government will reap revenue through taxes and royalties. Now, the last slide is what is it in for me? Or what is in it for me? As they say, knowledge is power, and the oil resource belongs to you and me, and therefore we owe it to ourselves to keep abreast and be informed on the discussions that are going on the possible opportunities and benefits that comes with this resource. I believe that when we are informed, we align ourselves better on when, how, and at which phase of the value chain to participate. And my colleagues will share more details on the possible career prospects, business ventures, and provision of services to the onshore operations. So thank you very much.